We first started using methanol as a road transportation fuel here in the United States. In the state of California, we introduced methanol flexible fuel vehicles and fueling infrastructure back in the 1980s and 1990s. Now, while we've seen the expansion of methanol production here in the United States driven by the shale gas revolution, today the story of using methanol as an energy resource is mainly a Chinese and European story. Now, I'm going to touch a little bit on the use of methanol as a fuel for road transport, marine transport, some emerging heat markets for methanol in China, and then I'll end up looking at methanol as a hydrogen carrier for fuel cell technologies. Now, the Methanol Institute was established 30 years ago. We promote the expansion of the global methanol market from our offices here in Washington, well, actually just across the river in Alexandria, and also we have offices in Singapore, Brussels, and Beijing. This is a listing of our member companies. We represent the world's largest methanol producers, distributors, and technology companies. They sell methanol in every corner of the world. Now, on a global basis, most methanol is produced from the steam reformation of natural gas. Mature technologies, plants that produce 5,000 tons per day, 600 million gallons a year. Basically take natural gas, desulfurize it, reform it into synthesis gas, which is a mixture of hydrogen and CO2. We then combine that and make liquid methanol. Now, you can also make that synthesis gas, again, hydrogen and CO2, from the gasification of coal. That's primarily done in China. Most of their methanol is produced from coal gasification. But you can also get those component features, hydrogen and CO2, from a wide range of biomass and renewable feedstocks. Now, once you take that synthesis gas and turn it into methanol, CH3OH, the simplest alcohol fuel, you open up a wide range of markets. Last year, total methanol global demand was about 83 million metric tons, 27 billion gallons. We're sort of on the scale of the global ethanol industry. 60% of our market is using methanol as a chemical commodity, a building block for hundreds of products that touch our daily lives. Paints, plastics, solvents, resins, car parts. But 40% of our market is the use of methanol as an emerging energy resource. And the fastest growing sectors of methanol demand are in the energy sector. Now, we have a number of pathways to produce methanol as a net carbon neutral fuel. You can take any biomass resource, municipal solid waste, forestry residue, gasify it to produce that synthesis gas that's used to make methanol. We can take biogas from anaerobic digesters, from landfill gas, wastewater treatment, dairy farms, and use that biogas to make methanol. One of our member companies is actually the largest purchaser of biogas here in the United States. They produce biomethanol in Texas that's actually sold into the European market, where it's considered a second-generation advanced biofuel and qualifies under the European Union's fuel quality standard. You can blend 3% methanol in gasoline anywhere in the European Union today. It's part of their fuel requirements. Now, you can also take any renewable electricity resource, solar, wind, geothermal, hydropower, produce hydrogen through electrolysis of water. Now again, to make methanol synthesis gas, hydrogen and CO2, the CO2 can come from a process waste stream, a cement plant, aluminum, steel mill, or in the future, near future, we'll see the direct air capture CO2. So literally stripping CO2 from the atmosphere. Combine renewable electricity, CO2, you make renewable methanol. That's a carbon neutral fuel, reduce CO2 emissions by up to 95%. And it's being done commercially today. Now, here in the United States, we produce our methanol from natural gas. Because of the shale gas revolution, over the last 10 years, in the 2010s, we saw a resurgence of methanol production. We had methanol plants that have been mothballed for a decade brought back to life. We have new greenfield plants being built in the United States. We had 2 plants that were literally cut up in Chile and moved to Louisiana to take advantage of the affordable natural gas here in the States. And more is on the way. We've got a plant that's being built right now in West Virginia using Marcellus shale gas. And there's another plant that's coming online later this year in Louisiana that's being built with some investment from China. And we've got a lot more plants that are on the way. Now, each one of those methanol plants will cost somewhere between $1.1 to $1.8 billion to build. We'll create thousands of construction jobs, hundreds of permanent jobs, and we'll use a lot of natural gas, about 125 million cubic feet a day, or 50 billion cubic feet a year. So a methanol plant is a huge consumer of natural gas. As we're building all those methanol plants, we're looking at mostly an export market. China is the world's largest market for methanol. China consumes more than half of all world methanol demand. The fastest growing segments there are the use of methanol as an energy resource, the direct use of methanol as a fuel, and then also MTO, methanol to olefins, olefins being the feedstock for plastics. Now, we also have tariffs. We've talked a bit about tariffs today. Methanol has a 25% tariff on both the US and Chinese side. The US went first, China reciprocated. Now, we don't actually import methanol to the US from China. We're building methanol plants here for an export market. China is the world's largest market for methanol. The Chinese don't want to sell us their methanol, they want to buy our methanol. That would reduce our trade deficit with China. But we have a 25% tariff. We also talked a little bit today about the phase 1 deal that was announced last week between China and the US. China has agreed to purchase $52 billion more in energy products from the US in the next 2 years. Methanol is on that list as an energy product from the US, but with a 25% tariff, it's kind of hard to compete on global markets, particularly when the main supplier of methanol to China is Iran. They're not facing a 25% tariff. Now, speaking of energy markets in China, one of the fastest growing markets there is use of methanol as a direct transportation fuel. The EIA put out a study 2 years ago now where they were looking at the direct use of methanol as a fuel in China at about 200,000 barrels per day. That use is as M15, 15% methanol blended with gasoline. So 15% methanol, 85% gasoline, used in the existing fleet of passenger cars as a high-octane fuel. More recently, we're seeing the use of M100, neat methanol, being used as a fuel for cars, trucks, and buses in China. In 2 cities in China right now, Xi'an and Guiyang, they have 20,000 taxis running on M100. Taxi drivers save 1/3 in their fuel costs every month using methanol. And if you look at those pictures, you don't really see a lot of blue sky in Xi'an and Guiyang. So methanol also reduces particulate matter, reduces local pollution. So it's cleaner and it's cheaper. The Chinese government last year announced a public policy promotion for the use of M100 in cars, trucks, and buses. It was driven by the Ministry of Industry and Information Technology and 7 other ministries, calling again the commercial introduction of M100 fuels. They've now approved 32 different vehicles from 9 different manufacturers of vehicles, heavy duty and light duty, for the sale and use of methanol fuels. In Europe, one of the largest integrated oil and gas majors, Eni in Italy, joined with Fiat Chrysler to look at how can we reduce CO2 emissions from today's cars. And they came up with an A20 blend for 20% alcohol, 15% methanol, 5% ethanol. Reduces CO2 emissions. They've demonstrated this in a fleet of Fiat 500 cars. They find that this A20 blend is a 100 RON fuel. And that's important because the automakers are always targeting 100 RON for more efficient, high-octane fuels. Methanol can do that. They also showed that this fuel is transparent to all E10 cars, which means that while both alcohols, methanol and ethanol, are slightly more corrosive than gasoline, there's no problem with using this blend, this high-octane, high-alcohol fuel blend in today's cars. In Germany, there's a program called C3 Mobility for closed carbon cycle. It's a program of the German government and the auto industry. What they're looking at is, again, how do we reduce the greenhouse gas emissions from the automotive sector? Their focus is on the renewable methanol molecule. So if you look at Germany, they're supposed to be a carbon neutral economy by 2050. To get there, you've got to use a lot of renewable energy. Now, Germany doesn't have the capacity to produce all the renewable wind or solar power that they need to get to their targets. They will have to import that renewable electricity in some other form. Now, in Europe, we talk a lot about e-fuels, electrofuels, power to X. It's taking that renewable electricity and turning it into a liquid fuel that you can now move around the world. So you can take solar power, solar wind farms in North Africa, turn it into liquid methanol and ship it into the German market. Germany expects that by 2050, 1/3 of their total energy fuels will come from this power to X. And methanol is one of the fuels that they're looking at. So under this program, they'll be demonstrating a wide range of light-duty cars and heavy-duty vehicles that are running on methanol and also derivative product. They'll take that methanol, turn it into gasoline, or turn it into other fuels like OME and DME that can be used in heavy-duty vehicles. Now, turning from road transport to shipping, the shipping industry is being driven by emission reduction requirements in the International Maritime Organization. This month, the requirements to reduce sulfur in bunker fuels went into place. By 2050, shipping is supposed to reduce their greenhouse gas emissions by 50%. Now, the ships that are going on the water today are going to be on the water for 20 to 30 years. So for shipping, they've got to make decisions now about how to meet their obligations for 2050. Methanol is one of the options for shipping. We've got a number of vessels that are on the water today. Some of these are ocean-going chemical tankers that are dual fuel capability. They can run on any diesel bunker fuel or methanol and can switch back and forth with the press of a button. And now we're seeing this use of methanol as a fuel as a hydrogen carrier in cruise ships. We're looking at also using methanol in workboats, tugboats, ferries. All can be used with methanol. Methanol is one of the most widely shipped chemical commodities in the world. Of that 83 million metric tons of methanol that was consumed last year, 60% moved from one continent to another. Any port where you've got large chemical storage tank farms, you've got methanol storage capacity. So we've already got methanol now available at 100 ports today. That methanol is in the port right now, and it's one of the most, again, one of those widely shipped chemical commodities in the world. In terms of cost, methanol has half the energy content of diesel, so you need twice as much. But even there, even though we need twice as much fuel, we're competitive with today's bunker fuels. Today, methanol is actually selling at a discount to low sulfur marine gas oil, so we can be competitive on a fuel cost price. In terms of bunkering methanol, it's a liquid at room temperature, ambient pressure. It's easy to store, it's easy to go from the port, from a bunker vessel, and then onto a ship. Methanol is also readily biodegradable. So if you had a spill of methanol, it's much safer for the environment than any of the diesel bunker fuels that are being used today. Now, to turn again, I want to talk a little bit more about China. So I've been to China many times. Every time I go, I hear about some new market for the use of methanol in China. China is now banning the use of diesel and coal in industrial boilers used for industry and residential heating. There are more than 1,000 boilers that have now been converted to run on methanol, about 2 million tons of methanol demand. So in China, they have less than 1/10 of the pipeline infrastructure for natural gas that we have here. So natural gas in many cities is not an option for these industrial boilers. If you take away the diesel, the coal, what are you left with? Methanol is an option, and it's actually in most cases cheaper than the use of natural gas, even if it were available. We're also seeing the use of methanol in clean cook stoves in China. Some of these are one-burner stoves used in residence, but mostly we're talking about large commercial stoves used in restaurants and central kitchens. And there it's 5 million tons of methanol demand. That's 1.7 billion gallons. And it's literally thousands of restaurants are using methanol as a clean cook stove fuel. This one picture there shows you a cook stove manufacturer in Kunshan. It's north of Shanghai. They've got a control room where there's a big screen. There's 1,000 points on a map. Each one of those points represents a commercial kitchen using a methanol cook stove. They're so sophisticated, they've got cameras in each of those kitchens. They can see how it's being used, make sure it's being used safely. They can control the methanol supply remotely. If a guy doesn't pay his bill, they can turn it down. They can also dispatch methanol through an app. You can just go on your phone and say, send me this much methanol, and they can ship it immediately. We're now seeing the use of methanol in kilns for glass and ceramic production. China produces 60% of the world's gas products. When you're using methanol to make ceramics For instance, methanol, again, the molecule is CH3OH. There are no carbon-to-carbon bonds, and it's carbon-to-carbon bonds that produce soot or particulate matter. So you actually produce a higher quality ceramic using clean-burning methanol, and it's cheaper than largely the propane that it's displacing. So it's cheaper and it's a higher quality. They're also using methanol for drying tobacco in China. Every third cigarette smoked in the world is smoked in China, so it's a big market. Also, if you look in India, they're now using methanol for drying tea in India, which is another emerging market. The newest market I heard about is the use of methanol for home heating. In one province, Shanxi, there's now 30,000 homes using methanol for heating. Another 50,000 will be added this year, and we're seeing that market also grow in China. Now, I want to just close quickly to talk about the use of methanol as a hydrogen carrier for fuel cell. As Deepka noted, there's a lot of hydrogen in methanol, CH3OH. It's got the highest hydrogen to carbon ratio of any liquid fuel. You can take that liquid methanol and put it on a car and reform it to hydrogen. So you can take a fuel cell, fill up a car with liquid methanol, and then use the hydrogen from that methanol to fuel a fuel cell. We're seeing applications in stationary power. It's typically cell phone towers or remote applications where they're using methanol instead of diesel generators or battery sets to run cell phone towers. Using it in soldier power. There are troops, US troops, that are using methanol instead of batteries, methanol fuel cells instead of batteries, and reducing the weight of the soldier power. And then we're also, again, seeing methanol as a fuel for fuel cell vehicles. Here we talk about methanol fuel cells making battery electric vehicle technology practical. So you take a methanol fuel cell, you fill up the car with liquid methanol, 3 minutes just like you do gasoline today. There's no infrastructure concern. There's no charging concern. There's no time lost to charging. Then that fuel cell charges a battery. It runs the battery. The battery is what you're actually driving the car on, and you're going to be reducing the weight of the batteries by 2/3 using that methanol fuel cell. So you've got a cheap fuel, you've got liquid fuel, a fuel that can be produced renewably. You can take a battery EV that might have a range of, I show kilometers here, but 300 kilometers. Now you've got a car that'll run 1,000 kilometers. So it's a range extended battery electric vehicle. And then some of this is actually taking place. One of our member companies in Denmark is now introduced or building a manufacturing plant. It's going to produce 50,000 15 kilowatt methanol fuel cells a year for mobility applications, range extended EVs. Another one of our members, Palcan, is doing the same thing in China, just north of Shanghai. A new manufacturing plant will produce 50,000 methanol fuel cell units a year. So this is real commercial technology. And with that, I just want to close with our contact information. I'm joined today by Larry Navin. He's our Director of Government Relations. And I thank you all for your attention.